All right, so today we're doing some more with geometry. We're going to especially focus on perimeter, circumference, volume, area, surface area, and sectors of a circle. So some vocabulary for today. Perimeter is the distance around a shape. Planar just means a 2D figure, a flat shape, like a rectangle that you draw on your paper. Area is how much surface it takes up, and we always measure it in squares. So like if you think of a hallway that has tile on the floor, or a bathroom with a tile floor, if it's got square tiles, it's how many of those squares does it take. Sometimes you've cut the tile, so you've got a little piece over on the edge. It isn't a whole tile. You add all of the little fractional pieces up to get how many total squares. Surface area is for a 3D shape, for a solid. So surface area is 3D. Plane area is 2D. Surface area, you take all of the sides of things, the faces, take the area of each of those surfaces, and then you add them all up. Lateral surface area, you don't count the base. So lateral surface area is a part of the total surface area. If you take lateral surface area plus the area of the base or bases, like a pyramid or a cone just has one base, but a cylinder or a prism would have two bases. You could turn it so it has a matching top and bottom. And volume is how much does it take to fill up the 3D shape. Volume will be measured in cubes. So if you took like sugar cubes, or if you took like those little alphabet blocks, and some of them you might have to cut down, grind down to sawdust, how much would it take to fill every little bit of that solid? Any questions about these? I do have a question in the chat about organizing papers. I suggest that you have your class notes labeled lesson 1, lesson A, lesson B, then lesson 1, lesson 2, all in order, so you can go back through those. I suggest you have your formulas in a separate list, either in the notebook or loose leaf, where you can easily go back and look up formulas that you've forgotten. And I suggest you keep your homework papers in order somewhere where they're easy to find before a test, to go back and look at the kinds of things that you missed. Anybody else need me to wait? You can just type wait, so it's not a lot of typing, okay? That's why I'm asking. Any of these that you're a little bit confused about, that you don't quite remember or understand the difference between? We will next move to where you're keeping track of all of those formulas, and we are going to have a whole bunch of them today. They should mostly be review. Some of them will be some vocabulary kinds of things, but we want to make sure that we remember what the formulas are and what these different kinds of shapes are. You may certainly hole punch, homework, whatever will work for you to keep them organized where you can find them. I hope that you find as you get older, we're giving you more responsibility to choose what works best for your learning. By the time you guys go on to college, nobody's going to require that you have to do your notes this way or that way. You need to be figuring out what helps you learn the best. And for my class, you guys are old enough and mature enough to do it the way that really works for you. I may give some suggestions, but the important thing to me is I just want you guys to learn this, and whatever's going to work the best for that. All right, hopefully we're in a spot where we can go on now and start in on those formulas. So somebody unmute. What's the area of a triangle? You've had this one for several years now. Somebody unmute and just tell me the formula. Oh, no wonder. I can't hear. I don't have my headphones on. Say that again. Okay, area, it would be the, well, we want to be a little bit careful because we can't have the area of a base when all that it is a triangle. Oh, I know what I've got wrong here. Grab that. It is base times height divided by 2. And so here's a triangle, and the base can be any side that we want. Is it okay just to do that? Is H one of the other sides? Somebody tell me, is that correct? Yes or no? Somebody give me an answer. Why not? What do I need to change? Specifically, the height needs to be at a 90-degree angle to the base. They must be perpendicular. They must form 90 degrees. And that side where I first wrote the H was slanted. It did not make a 90-degree angle. Okay, we had some different kinds of triangles that we learned in the past. Things like isosceles and equilateral. I took my picture over a little bit too far, but that's okay. Isosceles has two sides that are the same length, or two congruent sides. It also has two congruent angles, base angles, and they have to be exactly opposite the two congruent sides. So opposite this side would be this angle right here. Opposite this side would be this angle over here. If they tell you that a triangle has two congruent angles, you can say, oh, that means these other two sides have to be the same length as each other. If they tell you the sides are the same, that says, oh, I also know that the angles are the same. Equilateral triangle, all three sides are the same, and all three angles are the same, and in fact, they're all 60 degrees. Why do they all have to be 60 degrees? What do the angles in a triangle have to add up to? What is the sum of the angles in a triangle for that next one? Excellent, and thank you to those of you who are volunteering to shout stuff out. I love having the risk takers. Even if we're a little bit off, that gives us something to build on to be able to get to the right answer together. While some people are finishing copying down these slides, does anybody remember the name for the third kind of triangle? We'll get to this one another day, but for the triangle that has no congruent sides and no angles with the same measure, does anybody happen to remember that name? Excellent, great remembering. Scalene, S-C-A-L-E-N-E. Next thing we will move on to will be circles. So you might want to, in the spot where you're doing your formulas, just write the heading circles, and maybe even draw a couple of circles there, because we'll be talking about some different things on the circles that you might want to be able to label with these formulas. Do I need to wait, or are we good? Don't see any new comments going up there. So I've got a couple of them drawn up there, and I've drawn some lines on there and labeled an X in there. And first thing I want to talk about is the circumference. Circumference is like perimeter, and that would be if I go all the way around the circle, how far have I walked? Does anybody remember the formula for circumference? We actually have learned it two different ways. Come on, somebody be brave. What's the formula for circumference? Excellent. One of the ways we've learned it is 2 pi r, and because 2 times the radius is the same as going all the way across, we can also say pi d. Those are equivalent. Arc length is just part of the circumference. Arc length is, well, what if I only go part way around the circle? We've seen in other math problems that anytime we say of, it means times. So we want part of circumference. So part times the circumference, or a fraction times the circumference. So here's the circumference, pi d. The fraction would be, if it is 360 degrees all the way around the circle, but we're only going x degrees, x has to have, that's if we have the vertex right there at the middle of the circle. So the fraction becomes x over 360 times pi d, or x over 360 times 2 pi r. Next one is going to be area of a circle. And so area, as you guys know, is, well, if I shade the whole circle in, if I fill it in with little squares, how many squares do I need to fill in the whole thing? And so somebody please help me remember what the formula is for area. Excellent. It is indeed pi r squared. And since area is going to be in square units, it helps me keep them straight because the area formula has the square in it, pi r squared. So since I have square units, that needs the square formula. Circumference is just regular units, so it does not have anything squared in that formula. And we talked about part of the circumference. We're now going to talk about part of the area. A sector is like a piece of pie. So if I wanted just this piece of pie with that x degrees there, and I wanted to know how many little squares to fill that in, I would be talking about part of the whole area, fraction of the whole area. So just like we did with arc length, that formula needs to be fraction times the whole area. So x out of 360 times the whole area. And then we're going to have a section for volume and a section for surface area. And then we'll have time for some examples. So as you are waiting for some of your classmates to finish getting this copied down, be thinking about, how do you get the volume of a box? How do you get the volume of a triangular prism or a cylinder? How do you get the volume of a cone, of a pyramid? How do you get the volume of a sphere? Start letting some of those things kind of roll around in your head. If you're still copying formulas, please type wait for me. Or if you need me to go back, tell me back to which formula or whatever. Okay, don't see any new responses going up. So volume. So you see up here a couple of shapes that can be turned so that the top and the bottom match. On the left, it looks like a cylinder. It's got a circle on the top and the bottom, and the sides go straight up and down. The second one looks like I can turn it so there's a triangle on the top and the bottom that match, and the sides go straight up and down. So these are considered a cylinder and a prism. Anytime we have something with sides that go straight up and down, the formula is the area of the base times the height. We usually use capital letters when we're talking about things in a 3D shape, which is why the A, the B, and the H are all big. If you already learned the formula as big B times big H, that's fine, as long as you remember that it's the area of the base times the height. So we start with writing that down. Then we might substitute in, if it is a cylinder with a circle for the base, pi r squared, because that's the area of the base, times the height. Or if we had a triangle for the base, we might say, well, one triangle is a half little b little h, and then times the big H. And you see there why we need the lowercase and uppercase to tell us if we're talking about 2D or 3D. We could have other shapes. We could have irregular shapes, squiggles. We could have things that are a semicircle and a square put together, and then it goes straight up. You probably remember some of those problems from last year. If it does have a circle for the base, that's what I was just talking about, we would put in pi r squared for that area of the base, and then times the height. We call it a circular cylinder if the base is a circle. If it is a cone or a pyramid, so it only has one base, and then the sides slant. The formula is similar, but times a third or divided by 3. So it's the area of the base times the height divided by 3. And again, if it has a circle for the base, like this picture right here, we'd put in pi r squared times how tall that cone is, and then divide by 3. If we had I'm not sure if that's a square or a rectangle, so I'll say it's a rectangle, we'd take this side times this side to get the area of the base. Then we'd multiply by how tall it is, and then we'd divide by 3. So you just have to look at the shape and figure out, well, which formula gets the area of the base. If it is a circle, and you don't have to memorize these circular ones separately, if you've memorized the 1/3 area of the base times the height, this is just showing you do substitute in that area of the base is pi r squared. And then if we want the volume of a sphere, it is going to be 4/3 pi r cubed. And I'll scroll right back down to that in a moment. But for all of these volumes, they are always going to be in cubic units. So meters cubed, centimeters cubed, inches cubed, and so on. Anytime it's asking for volume, you will label your answers with cubic units. And our last group will be surface area ones. So you might want to write a heading of surface area before the next one. I've got a couple of heads I see still going up and down. Anybody need me to wait, or are we good? So I'll wait just a moment for the last few people to finish up. All right, let's get these last ones up there then. So surface area, because it is a kind of area, will be labeled in square units this time. So if I'm talking about surface area, if I want surface area, I'm talking about how much paint to cover the outside. And sometimes I might paint the floor, and sometimes I might paint the roof or the ceiling, and sometimes I might not. So if I don't want to paint the ceiling and the floor, lateral surface area is going to be perimeter of the base times the height. Again, since it is a cylinder or prism, it is going to have two bases and sides that go straight up. If I want the total surface area, now I'm including the floor and the ceiling. I'm including the two bases. I need the area of the two bases, so I get the area of one base, double it since I have two of them, and then I add all of the sides, that lateral surface area. So that formula should make sense. If we have two bases, we need the area and we want the total surface area, we need the two bases and we need all of the sides. And that's all that that formula says. If we happen to have a circular cylinder like this one up here, where these bases are circles, we have a formula for the area of the circle, and we have a formula for the perimeter or circumference of the circle. So we could then just plug that in, that the area of the base, the area of the circle, is pi r squared, so that times 2, plus, and we know that the circumference, the perimeter of the base, is 2 pi r, so we just plug that in. It's not a new formula to memorize, it's just plugging in what we already know. So those are all ones that have two bases. Our our next couple are ones that are cones, so that they only have one base. I would still do the lateral surface area the very same way. The lateral surface area would still be the perimeter of the base. Or actually, no, forget that. Sorry. It is different for that. We'd have to add them up together. Total surface area would be one base. And then because these sides are triangles, if it's not a cone, if it's a pyramid, little b times little h divided by 2 for one triangle, so it kind of looks like that. We have the perimeter of the base. This is the slant height. That's a cursive L. And the slant height would be, well, the true height is if I go down through the middle. But the slant height is if I go down through one of these triangles along where that pyramid slants. So I just go down, it's like the height of one of those triangles. It's the altitude of one of those triangles, but it's the slanted height of the pyramid. It goes from the perimeter, from the middle of one of the triangles on that perimeter up to the point. If it is a cone, I don't have the triangles, but I can still plug into this formula. If this is a circle, we have one base. so we plug in pi r squared for the area of the base. If this is a circle, we put in 2 pi r for the perimeter times the slant height divided by 2, and those 2's cancel out so that that part becomes just pi rl. And again, you don't have to memorize that formula separately. As long as you know this one, you can plug in what you know for circles to get how you would get the total surface area of a circular cone. So these have one base. That's what it means to be a cone or a pyramid. And the last one, surface area of a sphere is 4 pi r squared. Now, a lot of times students get the two for the sphere mixed up. I'm going to write the other one that we had on the last slide right here. The volume was 4/3 pi r cubed. Surface area is going to have square units. So the formula for a sphere that has a square in it is the surface area formula. Volume has cubic units, and the formula for the volume is the one that has the cube in it. If there is a 3, because one of them has 4/3 and the other just has 4, both of the 3's go in the same formula. So maybe those are some little things to help you keep those formulas straight. Everybody good to there? All right, let's do a couple of examples together. Anybody needing me to wait? I think we're good. So we want to get the arc length. And when you're doing these geometry problems, you always start with a specific blank formula. So a formula for that shape. So arc length, remember, is part of the circumference. So I need fraction. You don't necessarily have to write this. I'm just trying to remember how I do this. So let's see, my blank formula. Who could type in what my fraction needs to be? What is my fraction that I need on this one? Type that in the chat. Just the fraction. What fraction am I talking about? Okay, I guess we'll go with what Kira typed. I was hoping I'd have a whole bunch of you typing the same thing at the same time. So we would have 45 over 360. And yes, that will indeed reduce. We can worry about that in a minute. It does reduce to 1/8. And then of means times. And the formula for the circumference is either 2 pi r or pi d. I decide which one I need by looking at my problem. Let's see, do I want 2 pi r or pi d? Well, they tell me radius, so I'm going to choose the 2 pi r formula. So actually, I should have written, so the blank formula you'll start with is x over 360 times 2 pi r. This will be the first line in your problem. Then that becomes 45 over 360 times 2 times pi times 10. Then you punch in on your calculator 45 times 2 times 10 divided by 360, or you do it mental math. So let's see, 90 over 36, no, yeah, 90 over 36 times pi, and what will that reduce to? 5 pi over 2? Yeah, so that'll reduce to 5/2 pi or 2.5 pi. We'll label that with centimeters, and then you would punch that in on your calculator and get 3 places. Anybody have a calculator handy? Nobody's got your calculator there to punch that in for me? should be getting 7.854 centimeters. Tomorrow, be sure that you have your calculator with you and on as we start so that you guys can help me out with some of those calculations. Anybody have a question on that? Okay, let me do one more of these then. And so for this same picture, now I want to get the area of the sector, so I want to shade that in. So this time my formula is going to be the fraction times the area, so x out of 360 times pi r squared. So again, the 45 out of 360. And the radius is still 10. So I have 1/8 times 100. So 100/8 times pi, and I can reduce that to 25/2 times pi centimeters squared. That's my simplified pi answers. Anybody gotten the calculator on now to tell me what 12.5 pi is with 3 places? I will eventually get to where I'm doing, I don't know if I'll use Pear Deck or something else, but where I can ask some questions that I can see everybody typing in your answers and not just waiting and hoping there's one other person that does it. I need everybody participating so that you really learn this well. We should be getting 39.270 centimeters squared. Everybody good with that? All right, we are getting close to the end of the period. So your last few minutes, let's go ahead and start on the new problem set. Does anybody have questions? I see one there that I'll get to in a second. Questions or things you need me to go back to? When you're writing the answer on homework, I always want to, if it's a pi problem, and you've been doing this, you did this last year also, you always keep pi with the pi symbol and simplify the numbers as much as you possibly can. This could be either 25/2 or 12.5 pi. That is exact. I always want the most simplified exact answer you can give me. This one is rounded, and I also on pi problems want the decimal to 3 places. Notice I still put the 0 in there to show that it was accurate to 3 places, not just 39.27. If it was exactly 39.27 and the calculator didn't show me any other numbers after that, then I'd only do 2 places. Any other questions from you guys? All right, well, I thank you for being here and participating today. I am going to ask tomorrow, I want more people willing to unmute and shout answers out loud, even if it's a bunch of people shouting out the same answer at once. We had that going on in my other classes yesterday, and that was a lot of fun. I need you guys participating. I'm trying to learn the technology one step at a time and get you guys on board one step at a time as well, but we're going to get to where, I mean, obviously the days that some of you are here in class, you'll be answering questions and I'll be calling on you. I will get to where I'm calling on students at home as well. All right, have a great day then, and thanks for being here. You can go ahead and log off and get ready for your next class.